All right, on your notes, we're gonna skip single replacement. I'm sorry, double replacement right now, and we're gonna do combustion. So there's a little bit of combustion at the bottom of that page. So combustion reactions are when we have something's being burned in the presence of oxygen. So that means oxygen's a reactant and another substance. The ones that we are going to be looking at are when it involves a hydrocarbon or an alcohol. And an alcohol is a hydrocarbon. And if something's a hydrocarbon, it just has hydrogen and carbon. So this is an alcohol. The difference is that that the alcohol has a hydrocarbon plus a OH. That's what makes it an alcohol. Also makes it a little bit tougher to balance those equations. These types of reactions usually release energy in the form of heat or light. And in a minute, we'll look at some names of some common hydrocarbons, and you'll see that there are different kind of fuels. So this exothermic reaction, the energy is always often captured to then drive some kind of process, drive a vehicle or something else that might be happening at a plant. When you do combustion reactions with a hydrocarbon or even a hydrocarbon containing oxygen, you're always going to end up with the same two products, carbon dioxide and water. So on your practice today, your products for every single reaction are going to be carbon dioxide and water. So that's why you don't have to have your green sheet. So we're going to look at a hydrocarbon plus oxygen is always going to give you H2O plus CO2. So in these types of that reaction, the hydrocarbon is the only thing that will change. I'm going to put a delta, a triangle for change. So that means that really the only thing that ends up being an issue in these is balancing them. And sometimes they can be hard to balance. And we're going to look at a couple of different scenarios. But we'll just start with an easy one. I'm just going to rewrite this so I have a little bit more room to work. C3H8 plus oxygen is always going to give me CO2 plus H2O. So when you balance these, so we looked at an example quite a while ago, you're going to start with the carbon. Next will be hydrogen. And then finally, you will try to balance your oxygen. And the reason that you do that is because the oxygen is in two places in the product. So sometimes it's a little difficult to get balanced. So I'm going to do a tally with most of these because they can be a little bit harder to balance. So we'll just start and we'll see how many we have of everything. I have 3 carbon, 8 hydrogen, and 2 oxygen to start off with. And then on my product side, I have 1, 2, and my oxygen. Because I have 2 in my CO2 and 1 in my water, I have 3. All right, we'll just go in order. We'll start with our carbon. I need 3, so I have to put a 3 in front of my CO2, which is going to give me 3 carbon. And it's also going to change my oxygen because that oxygen is in that compound too. So now I have 3 times 2 is 6, and this other one for a total of 7. Once again, I'm not going to start trying to deal with that. So the next thing I'm going to do is my hydrogen. I have 8, so I will put a 4 in front of my water. That'll change that to 8. And now if we look at my oxygen, 3 times 2 is 6, and another 4 for a total of 10. Which is a nice round number, which is what we need in these because the only place I have oxygen is with this diatomic. So half of 10 will be 5, and that becomes my coefficient. So this would be considered an easy one because it's just real straightforward as far as the balancing goes. You don't have anything odd or anything that you have to do a little trick for. I'm going to look at this one next, and it's a pretty hard problem. Definitely harder than anything that you have on your practice. Before we go down there, these are common hydrocarbons. So a lot of times you will not see them written out as formulas. You'll see them just written out by names. It would be good to know these. So like I said, if we start looking at them, you can recognize some methane, propane, butane. All of those are really common, different types of fuels. So that means when they're combusted, they release a lot of energy and that's captured. All right, let's look at this hard one. C3, I'm just going to rewrite it so I have more room. That is a hydrocarbon because it has hydrogen and carbon, and we said sometimes it'll have oxygen. That makes it an alcohol. And it's going to combust in the presence of oxygen, and it's always going to give me CO2 plus H2O. Same products for each hydrocarbon combustion reaction. We're going to go through the same process and do us a little tally. All right, so start off on this side. I have 3 carbon. My hydrogen, I have 7 here and another 1 here, so that's a total of 8. And right now on my reactant side, I have 3 oxygen. And I'm going to go to the product side. 1 hydrogen is 2 and oxygen is 3, which is going to be pretty much what we'll start off with any product of these. All right, we're still going to do the same thing. So I'm going to start with my carbon and put a 3 in front of my CO2. So that changed my carbon, but it also affects my oxygen. All right, so now 3 times 2 is 6, and another one is 7. Well, darn it. Let's try that again. How about 7 right there? 3 times 2 is 6, 7. Where am I at? That's not right. I got myself all confused here. Sorry. It is 8 somewhere. That's what I have written down over here. Because I'm doing, I wanted a 4 here. That's what I wanted to give me 8. All right. Sorry. Sorry about that. And this oxygen cannot be even. Oxygen, I really have 3 times 2 is 6. So this is 10. All right. I think I'm caught up. So far, even though I made it harder than it had to be, this is just a regular combustion reaction. We haven't done any tricks yet. So right now it looks like we're good because I got enough nice even number to go in front of my diatomic, but you can't forget you got this one little oddball oxygen. So of these 10, I need to subtract out that 1 because I don't want to change anything here. If I change that, I change everything. So that means I need to find another place for 9 oxygen. Can I use that to be able to do that just using that diatomic? No, because once again, I need that even number. Okay, so we're going to do that little rule. See if I get myself. We're going to do that little rule where we're going to multiply everything by 2, all the coefficients. So I'm going to change colors. 1 times 2 is 2. Not going to worry about my oxygen because that's the whole thing that's giving me trouble. 3 times 2 is 6. 4 times 2 is 8. And now I'm going to regroup. And I personally have to clean up and get it kind of cleared out so I can see where I'm at. All right, now we're going to see, hopefully, if we can get something done here. So carbon, 2 times 3 is 6. Hydrogen is 7 times 2, that's 14. And then I have another 2 because I got 2 hydrogens to give me a total of 16. And at this point, how many oxygen do I have on the reactant side? 4, right? All right, now let's go to my product side and see where we're at. 6 carbon, 8 times 2, 16 hydrogen, and now good old oxygen. 6 times 2 is 12, plus another 8 would give me 20. So I need 20 over here. I don't want to put a 10 in front of this right yet because that's going to give me too many because I have some oxygen here. So in this compound, I have 2 oxygen. I want to subtract that out. I need 18 more. That's something I can do with the diatomic. So what I need to put in front of here? A 9. I personally think that's a pretty tough problem to balance. So we did like the 2 tricks. I'm going to show you all some examples where those are separated out. Like we did that trick where we had to get something even, and then we also did that trick where we had to take out some oxygen. Like I said, on your quizzes and on the test, there's nothing that you have to do that both times. So let's look at a couple of separate ones that aren't quite as hard. These are on your practice. So if you'll go to your practice, almost, yeah, it's kind of toward the last. I think it may be the last practice, last page of practice. All right, we'll look at number 2 first. So I'm going to tell y'all what ethane is because I know I don't have it memorized. There's ethane. So I want you to start there and see if you can get that to be a balanced equation. All right, what did we end up getting as a coefficient for ethane? Nothing, okay. And what about for oxygen? And what about for CO2? 2. And what about for water? 3. All right. Now, does anybody disagree with that? So I want you to look over here and tell me how many oxygen you have. 7. Got 7 oxygen. 2 times 2 is 4. 3 times 1 is 3 for a total of 7. So this is where you would have gotten, and then you couldn't have got any farther because you had an odd oxygen. So then you would have had to do that trick where you're going to multiply your coefficients by 2. So 2 times 1 is 2. Once again, I don't ever worry about this oxygen because that's what I'm trying to get fixed. 2 times 2 is 4. And 2 times 3 is 6. So now if we look at everything, I have 4 oxygen on each side. 6 times 2 is 12 hydrogen. And now most importantly, my 4 times 2 is 8 plus another 6 for a total of 14, a nice even number that I can put my 7 on up there. So once again, these are really easy to write, but a little bit more difficult to balance because of the oxygen situation. Is usually what makes it a little bit more difficult to balance. All right, I'm going to show you one more on the next page, number 13. It's just another little situation that we kind of touched on in the notes. All right. I have a hydrocarbon, but it has that oxygen in it. It's going to make it a little bit more difficult. It's going to give me CO2 plus H2O. All right, I'm just going to run a little tally: carbon, hydrogen, oxygen, carbon, hydrogen, and oxygen. And that's always where I'm going to start, see where I'm at. So my carbon is in 2 places, so I have a total of 4 carbon. My hydrogen, 5 and 5 would give me 10. And at this point, I have 3 oxygen. And then over here, I have my usual 1, 2, 3. All right, so we're just going to start our process. We're going to start with our carbon. I'm going to have 4, so I'm going to change that to 4. My oxygen, 4 times 2 is 8, and that little oddball one over here for 9. And then my hydrogen, I need 10, so I'm going to put a 5 in front of my water. 5 times 2 would give me 10. Now, most importantly, I'm going to see where my oxygen's at. 4 times 2 is 8, and another 5 from the water for 13. Which seems like it's a bad deal, but if I come over here and I look, I've got 1 oxygen sitting in there. I don't want to change that compound, so I'm going to subtract out that 1 oxygen, which means I need 12 more on my product side. If I need 12 more, then I can easily get that by putting a 6 in front of my oxygen. How do you just like take it out? What do you mean? Well, because if I go back a little bit. All right, so we were right here. And when I figured out how many oxygen I had on my product side, I needed 13. So I have 1 oxygen in that compound. I don't want to change that compound. I don't want to put a coefficient in front of that compound, because once I do, I mess everything up and I have to start all over. So that means I don't want to change that. I want that to stay as 1. So that means I have 1 oxygen already accounted for on my reactant side in that compound. That means I need 12 more. I have 1, I needed 13, now I need 12 more. That I can work with because I have that diatomic. And if I come and put a 6 in front of there, then 6 times 2 will get me my 12. So 6 times 2 is 12. That other 1 would get me to my 13. So those are some things that come up with these that make them a little bit harder to do. And those are kind of an idea. As I've said before, practice does make you better at these. The more you practice, the better you will become and the faster. I see that from the quiz grades that nobody believed me about that. But it is the truth. That's up to you. It will continue to be the truth all next week. Awesome. All righty, y'all got a little bit of time to do some practice.